guys, this is test 57 game 3. This is the famous Toy Dinosaurs game with the mauve dinosaur. It's a very difficult game, so if you had trouble with it, you're certainly not alone. This game is notorious. They give us 7 dinosaurs, I, L, P, S, T, U, V, and 5 of those will be selected, and each dinosaur that is selected will be assigned a color, G, M, R, or Y, green, mauve, red, or yellow. Now I've laid out a lot of rules here, but don't worry, I'm going to explain all of those. They tell us that we have exactly 2 mauves, so I put down 2 M's here. They say we always have a red stegosaur, so I put that down as well. And of course, I've got 5 spaces here going horizontally for the 5 selected dinosaurs, meaning that there will always be exactly 2 dinosaurs out. Now I've laid out some other rules here as well on the side. If we have I, then it's GI. If we have P, then it's YP. V and U conflict, so if V is in, then U is out, and if U is in, then V is out. Then finally, if we have both L and U, then either we will have not L mauve or not U mauve. So at least one of the two will always not be mauve if both L and U are in. So out of the 7 dinosaurs, I, L, P, S, T, U, and V, we can make a number of inferences regarding which ones can be mauve. Because we know that I cannot be mauve, P cannot be mauve, and S cannot be mauve. So I, P, and S are out of the running for being mauve. Now, due to the fact that we have only 7 dinosaurs, I've crossed off I, P, and S. That leaves L, T, U, and V to potentially be the mauve dinosaurs. However, we know that we can never have both U and V being mauve because they can never both be in. We know we cannot ever have L and U being mauve because of the final rule of the game. So actually, the 2 dinosaurs that could be mauve are actually very limited. We have very limited possibilities regarding who could be mauve. Only these 4 could be L, T, U, and V, but because of those limitations, the possible combinations of mauve dinosaurs actually end up being very limited. Either we will have L and T being mauve, L and V being mauve, T and U being mauve, or T and V being mauve. So we could create 4 different diagrams based on who might be mauve. But if you look at these 4 right here, we could make 4 diagrams based on each of these 4 being mauve, but we really would only need 3 diagrams because TU and TV are virtually interchangeable. I mean, T isn't involved in any other rules, so when T is mauve and we have one of U or V, we could just say T and then U/V rather than saying, TU and TV separately. So it's really just 3 different diagrams. We could have TLT, LV, and then T with U/V as the 3rd diagram. So 3 different diagrams are what I'm going to create here. So when we have LT in as our 2 mauves, we have, LT and S out of the running here. That leaves I, P, and U/V. We're going to have either I and P, I and U or V, and then P and U or V as our 2 things in from a total of 3. In the second diagram with L, V, and S in, U has to be out for certain, meaning that the other 3 will have to be, I, P, and T. So we're picking 2 out of those 3 right here to be our ones that are in. And in the bottom diagram, we're obviously going to have the other one of V/U out, leaving I, L, and P to be the 3 things that we're choosing from for the remaining 2 spaces. So 3 different possible main diagrams here representing all of the possibilities for the game. So question number 12 is a typical orientation question. We just want to take one rule at a time and apply that rule to all 5 choices looking for violations. So for example, we know that we've always got to have a red stegosaur in, so any choice lacking the stegosaur is automatically bad. So for that reason, D can be eliminated. Next, we also know that we have V and U conflicting, so any choice where we have both of them in is automatically bad, and for that reason we can eliminate A, which lists both U and V, and we can eliminate E, which also lists both U and V. So now we're down to B and C, and both of those might seem good at first glance. Of course, what makes this question difficult at this point is that they're only listing the dinosaur level itself, they're not listing the colors. So for that reason, it's a little bit tricky. But if you think about it, we have our mauves here, right? LT, LV, and then TU or V. So looking at B and C, B has L and U, but it also has L and T, so that could be this top diagram right here perhaps, right? That would work perfectly fine. But if you look at choice C now, with I, L, P, S, and U, they're not including 2 out of these 3 things in. I mean, they have L, which is good, but they don't have T, they don't have V, they don't even have T there, so it can't be this third diagram either. Therefore, they're not including 2 mauves. In order for this to work, they would need to have L and U to both be mauve, but that the final rule of the game violates that. So as such, C is a bad choice, and B is our answer for number 12. Next, number 13, if T were not included. So automatically the bottom diagram is irrelevant since it lists T being our mauve, so it has to be in, of course, and the top diagram also irrelevant because it has T in and T being mauve. So the middle diagram is the only one that we're going to use here. And we're not going to pick T from here, therefore it's I and P in, and of course I is green and P is yellow. So everything becomes fully determined when you lack T, leaving no ambiguity at all. So what must we include? So 4 of these things must be included, 1 does not have to be included. Find the 4 that could be included, that must be included, and eliminate them, and whatever remains will be the answer. So must we have GI? Yes, we have that right here, so A is gone. Must we have MV? Yes, we have that right here, so B is gone. Must we have ML? Yes, we have that right here, so C is gone. Must we have MU? No, U is out in this choice, therefore D is our answer for 13. I will look at E though. Yet YP, of course we have in the last column right here, so E is gone, leaving D. Next, number 14, a pairing of toys that could be included together. So unfortunately, back in our previous valid scenario, we're just running through the choices here. We never had GL, and then in diagram for number 12 wasn't even full because it was an orientation question, not including colors. So we're not going to be able to use any of our previous work here, at least going through choices A, B, and C. But if we look at our diagrams here, the top and second diagrams could never have GL because L is always mauve there. But in the bottom diagram, we could easily have GL. So I'm going to put down GL here and then say to myself, okay, I'm going to have one of I or P in as well. Now, we could have mauve velociraptor in the second column here. We could choose MV, and so we could easily have MV and GL. Therefore, we know it's possible to have both of those dinosaurs and colors in at the same time. Therefore, choice A is possible and is our answer to number 14. Next, number 15, if we had YT. So YT is never happening in the top diagram or the bottom one because in those diagrams we have MT. However, in the middle diagram, we could have YT in the last column here, for example, and then we'll have one of either I or P. So they're asking us here, what must be true? Must we have I in? I could be out and P could be in that remaining space as well, so A is gone. Must we have P out? No, we could have P in with T there, so B is gone. Must we have 2 yellows? Well, if we had P, we would have 2 yellows, but if we had I, we'd have only 1 yellow, the yellow T. So for that reason, C is gone. Looking at D, G, L. L has to be M in this case, therefore that actually couldn't work, leaving E by elimination for number 15. And if we look at it, MV, of course, is happening right here for certain. That's why E is our answer to 15. Next, number 16, if we had both I and U in. So U has to be out in the middle diagram, therefore the middle diagram is irrelevant, and we're dealing with either the top one or the bottom one. So if I and U were both in, that means that on the top diagram we're not having P, we're not having V. Both of those guys are definitely out in this diagram, and of course I has to be G. We don't know what color U is going to be though. In the bottom diagram, we could easily have I in, of course, and we could easily have U as well, so we're going to have mauve U instead of mauve V, and then we're going to have I in as well, so we're going to have either L or P as the final dinosaur here. So they're asking us, what must the display include? In either the top one or the bottom one, we're definitely having MT no matter what, therefore we have to have MT, so A is our answer to 16. Finally, number 17, if we had 2 Gs. So we don't really know which diagram we're dealing with here, of course. We could be dealing with any of them at first glance. So I'm going to put down just Gs on each of these 3 diagrams right here. And of course, we know that we cannot have P due to the fact that P is always yellow. So I'm going to cross off P from each of these diagrams since we don't have room for that right now. So each of the diagrams here becomes pretty much determined. For the bottom 2 are determined completely. The top one is determined, to a certain extent. We can't say exactly what though. So we're getting rid of all the P's here, and they're asking us what could be true. Could we have exactly one yellow? Of course, there's no room for that. We're definitely having MMRGG for all three diagrams, so for that reason, A is gone. Next, looking at B, T included and is being G. Can't happen on top, can't happen on bottom, but in this diagram right here, we actually are having TG. Therefore, we know it's possible, and B is our answer for 17.